Up where I left off, each part has its own point system. Each subsection or content area, language arts, math, science, social studies, and so on. And by looking at the raw scores, which is how many points you get in each section, they calculate the scaled scores by looking at the average of how everybody overall did, and then kind of figuring out where you stand in relationship to other people. Put it on that scale, which makes sense for some reasons, but not much sense to you or I. The next the next slide is really about what the student report looks like. And it really is pretty simple. It kind of breaks things down into where you stand in each section. There's more detailed information that follows, and you get the individual scores of each category and each subskill that you can then uh, use if you want to figure out where your students are. However, one thing that they do say in the test manual, and it's something that I really strongly believe in, is that these tests are meant for accountability. They're not really meant to guide your instruction that much at an individual person to person level. They can tell you if you've been misjudging a student or something about whether or not what you're doing really matches up with other standard practices, right? You could have a student who's not doing very well, but they take this test and they score really well. And it might just be that they're disengaged in school. They don't really try. They don't put much effort because they don't see it as something that's particularly important, or maybe they're not challenged. Likewise, you might have some students who are doing really well and they know how to get help. They know how to get help from their friends. They know how to get help from their parents, and so it's a lot of extra work. But they're building their skills, and if you're doing your assessment well, right, you probably are getting good evidence. But if they get into this other testing environment, they may not do as well, and then you might want to work on some kind of independent thinking skills with them to make sure that their mastery is at the right level. Could be a test taking issue, could be a language issue, it could be anything. But this is just one way where we have ideas of concurrent validity. We're looking at multiple sources of data to try to figure out where are my students at right at this time. Another common type of score that you will come across, even though they try to get rid of these things all the time because they're very confusing, are grade equivalency scores. This one we talked about over the weekend. Um, grade equivalencies again represent the median raw score for each grade. There are two values. The thing to the left of the decimal, the value to the right of the decimal. The example that I have here, fourth grader in May who receives a 41 on her assessment has a grade equivalency of 5.8, meaning she did as well on the exam that she took as the average fifth grader who took the test in May of that school year. Now, again, the key things here are that grade equivalency doesn't mean that you should be taking content in other grades. It just refers to how well you know the content in your own grade. So her grade equivalency score of 5.8 doesn't mean she should skip a grade. It just means she knows her content well. Okay? A couple things to consider or to remember about grade equivalency considerations. One, don't interpret a grade equivalency as an estimate of the grade the student should be in. Right? We just said that. I can't say it enough because that's the mistake that parents make. That's the mistake that some teachers make. There are content differences, content shifts, content changes. Just because you know fractions really well and you can add, multiply, divide does not mean you should be taking calculus or algebra or geometry, because those are totally different things. Second thing, don't expect that all students should gain one grade unit each year. Development varies, skills vary. Sometimes I'm sure you can recall from your own history that some grades things just clicked, the concepts clicked, whether it was life science or earth science, say you're talking about sciences, right? Those are things you got. Likewise, in social studies, maybe you really liked studying about American history and you were really into the Civil War, and then all of a sudden the next year you're talking about, I don't know, foreign markets or something that happened in China or Africa or South America or the Revolutionary War, and you're like, oh, I don't really know that much about that, and it doesn't make a lot of sense, right? Um, so don't expect that growth will be even. Third, don't assume that the units are equal at different parts of the scale. So in other words, if I'm really high one year, it's going to be harder for me to maintain that. Just like if I'm really low one year, it might be easier for me to catch up, or I might just kind of go back to the average. Fourth thing, don't assume that scores on different tests are compatible. Grade equivalencies are computed individually for each test that they're administered with, and therefore how people perform or how students in other grades perform on those tests is going to vary a lot. So don't think that you can transfer grade equivalencies from one test to another. The last point is just because of how norm reference tests are typically set up, don't interpret scores at the extremes as a reliable estimate of student performance. And what that means really is that because these tests are designed to rank people or sort people, I'm going to have a ton of questions that are kind of middle of the road. And I'm not going to have any super, super hard questions, and I'm not going to have any or many really, really easy questions. Now, for somebody who's an advanced student, I don't really have many questions that really test them. And I don't really have many that ways to figure out exactly where they are. Just like the students who are really low, I don't really have many questions that are geared towards them. And so they just tend to get almost everything wrong, and I'm left to wonder where exactly they are. Now, this is a problem that computer adaptive testing solves, and we'll get to that later on when we talk about it. But these are the things to remember about grade equivalencies. The next type of scores are Stanines. And Stanines, you can see on the bottom row here, again, they go from 1 to 9. They're just like percentile ranks, which we're going to talk about in a minute, except they are simplified. And each Stanine represents a 1/2 standard deviation unit. So if I'm looking at the middle of the road, the Stanine 5 is 1/4 standard deviation above the average and 1/4 standard deviation below the average. So it's like the middle half standard deviation. And then it moves out 1/2 standard deviation towards the top and 1/2 standard deviation towards the bottom in increments. Now what that gives you is you get different numbers of people in each Stanine. And the key things to know that I'm going to hold you responsible for. One, that low numbers means that you did poorly. Okay? High numbers mean you did well. Pretty simple. Second thing is that there are unequal numbers of people in each one of the Stanines. Most of the people are in the middle, right? Because most people perform around average, and therefore you have about 20% of your people in Stanine 5. When I get down to the extremes, I only have 4 in Stanine 9 and 4 in Stanine 1. That can be confusing. It doesn't make a lot of sense. We're going to talk about why these don't really matter. I would like to get rid of them, but I still see them out there. They're still used, so you should know what they are. There's no reason why you should ever use these. The original reason they were used was because it was easier to write one number rather than two, and it was easier to store it in a computer back when we had severe data limitations by just writing one number for people rather than two. Now we've overcome that problem, but for some reason these things still remain. And any argument you hear about why they're still useful, think about it carefully and you'll find out that it's not a very good argument. Okay. Which leads us to percentile ranks and ranges. Okay. Now, on this particular graph, right, the idea is that the dot or the diamond represents the actual percentile rank, and the bar represents the range. And what this really does is say that, well, the diamond is what you got, and it's kind of where you fit. And we'll talk a little bit more about what it means exactly in a minute. And the bar represents the idea that I know that not every test is perfect. And so I'm going to say that my best guess is the diamond, but you're probably somewhere on the bar. Not a guarantee, but it's pretty likely that if you tried your hardest, your true ability is somewhere on that bar. Okay. Now, when we talk about percentile ranks in particular, what we're talking about is what percentage of people in the population that we're comparing ourselves to did as well as or worse than us. So if we want to flip it around a little bit, it's the percentage of people below or equal to our particular score. Okay? Couple things to note. One, percentile ranks are different for every test and within each testing area. They're also specific to the time the test was taken. So if I'm comparing myself to fifth graders in the beginning of the year, right, that's different than me comparing myself to fifth graders at the end of the year, where they've probably learned something, hopefully, right? Number three, they are also specific to a group of test takers. So if I'm looking at a district test, I'm only comparing myself to people in the district. If I'm doing a state test, I'm comparing myself to people in the state and say that it's public schools in the state. Well, then I'm not comparing myself to private schools or students in private schools. If it's a national comparison, national test, now I'm comparing myself to fifth graders in the nation, right? So the norms that I get, the values I get are specific to who I'm comparing myself to. It's also specific to conditions. And different tests, even though I might have the same question banks, might have different rules and different times for administration in different areas. So I want to make sure that the conditions are all equal and that it's a standardized process. Now, if you look down here, you'll see that one thing about percentile ranks, right? So say that you get a percentile rank of 98%, which means that you did as well as or better than 98% of the people who took the test. If I scroll around, and look across the different values or different content areas, I'll see that different scores correspond with that value of 98. And that's totally fine, right? Because it's breaking it down to what percentage of people scored as well as or worse than you on this particular test. And sometimes, if it's a difficult test, the points won't be as high as if it were a really easy test. Now, things to remember about percentile ranks then. One, always remember the norms for particular groups. Two, we need norms for any group we want to compare, and they're not always there. So sometimes we want to make these comparisons, but we can't because we don't have the data to do it. Note that when we are trying to make comparisons, we need to have a standardized procedure to compare apples to apples. And this is why when we talk about standardized tests, we're typically talking about norm reference tests. We can also be talking about criterion reference tests too, but we're typically talking about norm reference tests. Third point, changes in percentile rank are not consistent across the whole range of scores. And the idea here is that when we are kind of bunched up in the middle, there's so many people in the middle of the distribution. I'm going to skip ahead here for a second to this. Right, this is the normal curve. This is a great slide to get a tattoo of or put on a t-shirt. Be a great conversation piece during the holidays. But the idea here is that when we look at the normal distribution, right, it just means that there are a lot of people who are average, and as we get farther and farther away from average, there are fewer people both on the high side and on the low side. That means that when I change my score 10 percentile points, well, if I'm in the middle, maybe getting one more question right is going to bump me ahead of 10% of the people. Because if it's a 40 question test, right, a lot of people scored right around maybe 22, 23 points. I get one more point, I'm going to move up really far and fast in those percentile ranks. Where if I'm at the very, very tippy top, right, I got 42 of the questions right out of the 44, getting one more maybe will put me ahead of one other person, or maybe 10 other people, but a very small percentage, right? So that's another thing to consider when you're thinking about how changes in scores really move you a lot. And the difference between somebody who's at the 40th percentile and somebody who's at the 60th percentile might actually be very, very small, maybe one or two questions. Now this brings us to our last measure, and another one that again isn't that great, not very intuitive. It's very similar to scaled scores, it's just another type really, but they're called normal curve equivalents. And basically what it does is it takes the z-score and matches it up. So a score of 99 equals the 99th percentile, a score of 50 equals the 50th percentile, and a score of 1 equals the 1st percentile. But everything else doesn't match up. The key reason they do this is for statistical analyses. It allows you to calculate averages and do some statistical tests that you as a teacher probably will never ever do. Um, I don't think that they're that useful. I think that they are directly related to z-scores and to percentile ranks, but they try to pass them off as something that is not. Um, and even though one of the big things they say is that it gives you kind of an equal interval between different values. So in other words, the difference between a score of 1 and 2 is the same as the difference between 32 and 33, where when we're talking about percentile ranks, that doesn't always hold. Because there are so many people at the different percentile ranks in the middle and very few at the edges. So moving one percentile rank or one percentile point doesn't necessarily equal the same thing across the whole range of possibilities, where they say that this does. But I don't really know what that means in a real practical sense. I've never heard a good explanation for it. I spent some time thinking about it, and I can't think of any useful interpretation that would help you talk to parents. Um, so in this case, just recognize that they're similar and they're tied actually to, you can do a direct mapping to percentile ranks. But again, that's the only kind of way that you can get any kind of meaning out of these things, tying them back to something that they're trying to distance themselves from. So now back to this slide. This is a really great slide that kind of shows you the breakdown of how everything fits together. Here's the normal curve. We have our z-scores here, which is great. I have Stanines. I have some IQ scores. I have t-scores, z-scores, normal curve equivalents here. Uh, Basically, it's all different ways of trying to represent how people are different. And that's all it's really trying to do. Now, the norm referenced idea is important because you should know where you stand relative to other people because that's who you're competing with. That is what ultimately determines what is really good and what is not okay, right? And it determines the standards that you're going to have to meet. So this is a really important element, and people have spent a lot of time trying to figure out good ways to represent this, good ways to calculate it. But without specific standards or criterion referenced measures, it's kind of worthless. When we talk about criterion reference measures, what we're talking about are really setting a standard of what it means to be good at something and then comparing people to see whether or not they meet that standard, whether they're close, far above, far below, or whatever. Now, two that you will come across are either the Standard Performance Index. This is currently on the forward exam in Wisconsin. And it's kind of like a percentage. It basically tells you how many items you would have gotten correct if there were 100 items on the test. Now, they factor into this the difficulty of the items, possible guessing factors, um, and basically using a lot of fancy probability functions. And they come up with it, but it's basically like the percentage of questions you got right. It's pretty close to that typically, and it's a simple way to think about it. Sometimes this is called the Objective Performance Index. Again, it's the exact same thing, just a slightly different name. What it looks like in practice is something like this. This isn't how it looks on the forward exam. This is a different standardized test, but it gives you an idea. I think this one's actually a little clearer. You have all the different content areas. You have some different measures here and here, and then you have these little graphic representations. If we zoom in on one of those, we see social studies. And I see that I have a couple different columns. One is the student's OPI in this case, same as the SPI, which means that this again is the kind of percentage of questions you got right, or the percentage of questions you would be expected to get right if there were more questions on here. There's also the national average, right? This is what in the nation, how many questions people are expected to get right. And then this is the difference between the student and the national average. It also maps out the moderate mastery range and puts you in a different category of no mastery, moderate mastery, and mastery. If you look at here, this representation, a full circle means that you have mastered content. A half circle means that you have partially mastered or moderately mastered some content, and if you fall below the graded area, you are not displaying mastery, right? Note that the gray bar changes for different content areas. It also, you should also note that moderate mastery starts usually around 50% and usually ends around 75%. Again, in most cases, these tests aren't designed in a way that everyone should be getting every question right. Ultimately, they're designed to tell people apart, meaning that I'm going to want to be able to distinguish between people. If I made all my questions really hard, everyone would get a 0, and everyone would look the same. If I made all my questions really easy, everyone would get 100, and again, I'd have the same problem. Now, when we look at the forward exam, again, I have my student points. I also have my SPI value here. And then I also have my SPI level, and this is where those different performance categories come in. And this is really what parents will care about. This is what we report out. This is what things like No Child Left Behind cared about, right? Where are we going to draw that line? And if we had more time to do this, these are getting kind of long, and I know they're not incredibly exciting, but different states have different standards. And if you look across all the different states, you'll see these huge differences in what constitutes proficient. And therefore, states have different percentages of students who actually meet that value. Some states, like Connecticut and Maryland, have very high standards, and other states, like New Mexico or Mississippi, have very low standards. And even with that, you have these huge percentages of students who are not proficient. But a great organization called NWEA does all this work that kind of connects and compares across different states, so people can compare apples to apples, and you can kind of figure out where Wisconsin stands or where your state stands. Illinois, if you're from Illinois; Minnesota, if you're from Minnesota, where your state stands relative to the nation. And that gets out. Wisconsin has a pretty good reputation. Places like Mississippi, Arizona, and New Mexico don't. And states work really hard to change that, but they face a lot of other challenges. And basically, if your state is kind of poor, you will have lower standards and lower test scores. Now I'm going to stop here so I can upload this, and then I'm going to have it come back and have a part 3, which will be just about adaptive tests.